This is one of the questions that you see on your final exam practice. The first question here is to ask you to construct a 90% confidence interval for the population standard deviation sigma if a sample size 8 has the standard deviation s equal 20. So they are giving you the n to be 8 and s to be 20, and we know that we can construct the confidence interval for the standard deviation by using the formula the square root of n minus 1 s squared over chi-square of the right side, and then n minus 1 s squared, and this is chi-square of the left. Alright, so we see that here all we have to do now is to find the chi-square of the right tail and the chi-square of the left tail. Now they give you the 90% confidence level, right? So you know that your alpha is going to be the order 10% or 0.1. Now if you draw the chi-square, we know that the chi-square is not symmetric and it's stacked from 0 and then it's go all the way to the right, and we have here is the right tail and here is the left one. So this is chi-square of the left and this is chi-square of the right, and we know that this is 0.1 is for alpha, so we take alpha half here and alpha half here, right? Because we know that this region is 90% confidence level, and then the other two they are 10%. So each will have 0.05, right? 5% each. So this here is 0.05, and this one here is also has the area of 0.05. So how do I figure out what is the chi-square of the right side of 0.05? Now remember n equal 8, that means your degree of freedom is equal to n minus 1 or a minus 1 or 7. If you use the chi-square distribution table here, we can figure out what is the right tail of the chi-square given the area to the right of that is 0.05. So this is the area to the right of that critical value. 0.05 is here, and the degree of freedom is 7, so that's going to be here 7, 0.05, so that's going to be 14.067. So chi-square of the right, the critical value is 14.067, and then the one for the left, again this gives you all the area to the right only. So you need to figure out what is the area to the right of the left tail. So the right means the value from here and then all the way to the right. What is the area to the right of this left tail? Now you know that this is 0.05, so the green portion to the right of the left chi-square is 1 minus 0.05, because everything is what? Everything under the curve is 1, so 1 minus 0.05 will give me the area to the right, or 0.95. So we look for 0.95, the degree of freedom is 7, that's going to be 2.167. So 2.167 is my my left chi-square, 2.167. And now if you plug in everything here, this is 8 minus 1, s is 20 square, divided by chi-square of the right, which is 14.067, and then sigma, and then n minus 1, and 8 minus 1, s is 20 over chi-square of the left, is 2.167. If you do the calculation right here, you will get 14.108. And then if you do the same thing to the right side, you will get 39.945. And this is what is the confidence interval for the standard deviations. And let's see what is the answer for this one. And that should be A, right? The first choice, 14.11, and then 35.94 is your upper bound. Okay, so that's one of the questions. Okay, let's try the next question. In this question, they ask you to find the critical value for 99% confidence interval using the chi-square distribution with a degree of freedom with 20 degree of freedom. So we know that the degree of freedom df is equal to 20, and we also know that the degree of freedom is equal to n minus 1, the sample size subtract 1. So if you have 20 degree of freedom, your sample size should be 21. Okay, and again they give you what? They give you 99% confidence interval, right? Confidence interval 99%. Then that means your alpha is the order 1% or 0.01. And now we are looking to get the critical value, right? The critical value of the 99% confidence interval. And the critical value means they are looking for the chi-square of the left and the chi-square of the right. So how do I do that? Well, let's draw the figure of the chi-square. Again, the chi-square is not symmetric. We start from 0 and all the way to the right. 99%, so let me put the left side. This is chi-square of left, and this is chi-square of the right. And 99% means the entire middle region, right? 0.99. And therefore 0.01 is the area of these two tails. And if you divide by 2, 0.01 divided by 2 is 0.005. 0.005. And this is the area here, and also the area here. Now, to find the critical values of these two chi-squares, it's pretty easy. So for the right tail, right, we have the area of the right side 0.005. So go back to this here, 0.005 is right here. The degree of freedom is 20. So you want to go all the way to down here. Oops. All the way down here. This is chi-square. So 20 is here. So 20 is this row. And 0.05 is the last one. So the last one of 20 is 39.997. 9.997. That is a chi-square of the right tail. Okay. And to find the chi-square of the left, you need the area to the right. So from here and all the way to the right, what is the area? We know that this is 0.005 is the left portion. So whatever remains on the right side is 1 minus 0.005. And 1 minus 0.005 is 0.995. 0.995 is the area to the right of the left chi-square. So 0.995 is the right area, which is this column, and then you want to get to 20, so 7.434. Okay, so 7.434 0.34, and that is your critical value of the left and the right. And let's go back to the figure here. Which one is our answer? The left chi-square 7.434 and the right chi-square 39.997. So the first choice is your answer. This is the next question. In a simple random sample of 29 law students, 13 of them are women. You wish to determine that less than half of the law students are women. So in this question, they ask you to find if less than half of them are the women. So they ask you for the ratio, which is the proportion. So in this test here, you are looking for the test for the proportion. Okay, test for the proportion. So if you see that the test for standard deviation not correct, test for the mean not correct, the mean is also not correct. So there's only one choice, which is test for the proportion. So the last choice should be your correct answer, because you wish to determine if less than half of the law students are women. Less than half means you are looking for the ratio, the proportion of that. So this is a test for proportion. There's only one choice. Okay, all right. Let's move to the next question. Okay, this question is the hypothesis testing question. So in an attempt to increase the business on Monday nights, a restaurant offers a fish desserts with every dinner order. Before the offer, the mean number of the dinner customers on Monday was 150. So this is the mean. They are talking about the mean, right? The mean number. Mean is mu. Okay, mean is mu. The following are the numbers on the dinners on a random sample of Mondays while the offer was in effect. So this is the number of dinners. Can you conclude that the mean number of the dinners increased while the offer was in effect? So originally, they said that the mean of the number of the dinner customer on Mondays was equal to 150 originally, and they test the claim whether it will increase when the dessert was offered to the customer. So that's mean increase mean the mean will be bigger than 150. This is the claim, and this is your null hypothesis. This is your alternative hypothesis, and this value here 150 is a mu naught value. Alright, so how do I test this one here? Well, we are not given alpha is 0.05, and we also assume that the population is normally distributed. So even though the sample size is less than 30, but there is the assumption that the population is normally distributed, so we can skip the checking of the plot, right? All right, so now it's time to go back to the lecture before. So for the mean, when the standard deviation is not given and the population is normally distributed, then we use a student t distribution, and the student t distribution has a statistic of t naught equal x bar minus mu naught s over square root of n. So t naught equal x bar minus mu naught over s over the square root of n. Mu naught is the assumed value, the original value. We got that. We don't have the x bar, we don't have s, right? In this case, go back here. The n value, we have 1, 2, 3, 4, 5, so n is 10. N is 10 samples in this case. But how do I find x bar and the x bar and the s? X bar is a sample mean, s is a sample standard deviation. We can do this by my TI-84. So if you have a TI-84, first you're gonna list the data start edit. You're gonna list all the number 181, 172, 153, 142, 160, 156, 144, 152, 176, and 172. Now you're gonna go to start calculate one variable statistic, and then input L1, the list you just enter, and then hit calculate, and it will give you X bar 160.8, and your S sample standard deviation 13.69. So 13.69. Now you have everything, which you can find the statistic. So 160.8 minus mu naught is 150. Their sum value S is 13.69 over the square root of n is 10 in this case. And now you can also find this value. So 13.69 divided by the square root of n. Let me get the value at the bottom first. And then you're going to take the top, 160.8 minus 150, and then divide by whatever you just got, or the answer. And that will give me 2.495. Alright, so now this is pointing to the right, right? So this is the right tails. The right tail test. So if you draw the student T, 0 is right here, T naught is right here. So right tail test, that means you are looking for this area, 2.495. So you are looking for this area to get the p-value. P-value is the area of the right side of the test statistic. So this is the T, so you're gonna use the second distribution, second distribution, TCDF. The lower is this value, 2.495. The upper is the huge value to the right side. Okay, the real freedom, we have n to be 10, so the real freedom is n-1, or 10 minus 1 is 9, and that's gonna be p-value of 0.017. This one is less than alpha. So if its p-value is less than alpha, then we reject H naught. Reject H naught, which is this one here. Reject H naught. There is sufficient evidence to conclude that the mean number of the dinners increase while the alpha in effect. Recheck H naught, because if we recheck H naught, then we have enough evidence to conclude that the mean number of the dinners increase. That means we support this one. If we reject the H naught, then we support this one. So which is the mean number of dinners increase while the alpha was in effect.